Welcome to the last of the videos in this unit. This video deals with using special line segments in proof. All we're going to do during this video is we are going to use the given information to draw some conclusions about our diagram and then justify why we can draw those conclusions. So in number 1 it says BD, segment BD is a median of triangle ABC. Well, we need to know what a median is here. Remember that a median joins midpoint to a vertex. So if segment BD is a median, what that means, since B is the vertex, is that D has to be a midpoint of side AC. And the reason for that is, by definition, the median joins vertex to a midpoint. We wanted to be even more specific, we could say midpoint of the opposite side of the triangle. Hopefully you're realizing and understanding how we could use this in a proof. We could then use the midpoint to go ahead and prove a pair of congruent segments, use the segments to go on and prove a pair of congruent triangles, so on and so forth. All right, but in the meantime, I'm going to go ahead and move on to number 2. Number 2 says segment ID is an angle bisector of angle KIM. So the first thing I'm going to do is go find angle KIM. Segment ID is an angle bisector. I know that an angle bisector divides an angle into two congruent angles. So the conclusion that I can draw is that in this picture, the angles that I labeled 1 and 2 are congruent. And as for a reason, an angle bisector forms or creates two congruent angles. And again, hopefully you're seeing how this could be used in a proof. Up at the top of the next page, we're given that segment AC is a perpendicular bisector. So perpendicular means forms right angles. So that means segment AC will form right angles with segment BD. And by virtue of the fact that it's a bisector, we also know that segment BC is congruent to segment CD. So the conclusions that we can draw here, number 1, we can say that segment AC is perpendicular to segment BD. Or in other words, that angles 1 and 2 are right angles. And the second conclusion that we can draw is that segments BC and CD are congruent to each other. And as far as justification, that's because perpendicular segments form right angles. And secondly, the word bisector forms congruent segments. All right, number 4 deals with altitude. It says segment AD is an altitude. Well, I know by definition that altitude is going to be the segment that joins any vertex to the opposite side in such a way that right angles are formed. So the conclusion that I can draw here, I know that segment AD is going to be perpendicular to segment CE. And the reason, well, by definition, the altitude of a triangle or rather than say forms, I'm going to say is perpendicular to the opposite side. All right, and the last one, number 5, says segment DE is a mid-segment of triangle ABC. So that actually tells me a whole lot. I know that D is the midpoint of side AB. And I also know that E is the midpoint of side BC. And that's because by definition, the midsegment is the line segment that joins any two midpoints. I know midsegments are always parallel to the third side of the triangle, so I know that segment DE and segment AC are parallel. And the reason I know that, again, is that the midsegment of a triangle is parallel to the third side. And the last piece of information I know by virtue of the fact that DE is a midsegment is I know that the length of side DE is half that of the length of side AC. And the reason I know that is that the length of a midsegment is half the length of the third side of a triangle. As always, if you have any questions, feel free to write them down in the margin so that you'll remember to ask the next time that you come back to class. And as always, thank you for the gift of your time in watching the video. To have